All right, so today what we are going to be talking about is the continuation of three variable systems of equations. And I want to apologize for not being in class. I am on a trial, jury duty, all that wonderful good stuff. So I should be back on Tuesday of next week. Okay, so go ahead, take out your notebooks if you don't have them already out. And if you need to pause this video, please do so. I want you to copy down this problem exactly like you see it. Notice that I've lined up my x's with the x's, y's with the y's, z's with the z's. If you are not in class on Tuesday, please stop this video, watch the other one that's on my website about three variable systems, so that way you have a better understanding, because these are very specific types of questions that we're going to be dealing with today. All right, so now that we have this problem copied down, so what I want to do is I want to eliminate a variable. And again, it's whatever variable you want to eliminate. I notice that the x's are going to be probably very easy to eliminate. And I like to label. So I'm going to label that 1, 2, and 3. So that way I know which equation I'm dealing with and at what specific time. Okay. So first thing I'm going to do is, looks like without manipulation, is I'm going to add the first equation and the third equation together because they have opposite x's. So first equation, 2x plus y minus 3z is equal to 4. Oops. There we go. And then minus 13z is equal to negative 8. Beautiful. So add these equations up. You're going to notice the x's cancel out. 1 plus 3 gives you 4y. And then minus 16z is equal to negative 4. Now, before I call this my fourth equation, I notice that 4 goes into all three terms. So I'm just going to go ahead and simplify it right now. Make my life a little bit easier. So I'm going to get y minus 4z is equal to negative 1. Brand new equation, never seen it before. So call that number 4. Okay, going back to the top. Again, which two equations can I add together to still eliminate the x's? I've already used 1 and 3, so I got to use 2. And I think 2 and 3 are going to be easy to add together because I only have to manipulate the third equation. And by multiplying both sides by the number 2, I can easily manipulate that equation. So my second equation is 4x plus 2z is equal to 10. And then my third equation will be negative 4x plus 6y minus 26z is equal to negative 16. Boom, add them up. What do you notice? X's cancel out. 6y minus 24z is equal to negative 6. Again, notice that this brand new equation that we've discovered and created can be simplified. So I'm going to simplify it by dividing everything by 6. So I get y minus 4z is equal to negative 1. Call that brand new number 5. Now, at this point right now, you're probably noticing, if you can see it, is both the 4 and 5 are exactly the same. So if I add those, if I manipulate one equation, everything is going to cancel out. So I'm going to go ahead and multiply this one by a negative 1 to both sides. So brand new equation 4, y minus 4z is equal to negative 1. New 5 looks like this. Boom, add them up. Cancels out, cancels out, cancels out. 0 is equal to 0. Yay! Okay, so when we talked about two variable systems, when things are left, variables cancel out, you're left with a true statement. Then we have what's known as infinite, many solutions, right? But what we want to do is we want to do something a little bit more. We want to actually find out what could be a solution to this problem, right? So true statement, right? True statement infinite many solutions. Okay, so what do we do? Because this will no longer be an acceptable answer when we're dealing with true statements. Okay, false statements, it'll just be false. But for true, what we want to do is we want to figure out what we could possibly put in. So what we're going to do is we're going to write a let statement. And my suggestion is always keep it with the Z. These are fairly easy ones. You could put it with anything that you want. But again, I have been dealing with let Z equal something else. So what I'm going to do is I'm going to write a let statement. So I'm going to say let Z equal, and pick a variable. Okay, your book is using the letter A, so we're going to use the letter A. All right, so the second that I write a let statement, I get to use substitution. So that means everywhere I see a Z, I get to plug in A. So this would be 3A, this would be 2A, negative 13A, all that stuff. So now what I want to do is I want to solve for X and Y in terms of A. So that means the only variable I should see is the letter A. So what should we do? Right? What we should do is go back to either the fourth equation or the fifth equation. Doesn't matter, they're exactly the same. And what we're going to do is we're going to plug in that let statement. We're going to let A equal the Z, and we're going to solve for Y. So what does this look like? So if I take the Y minus 4, and now I'm going to write an A instead, is equal to negative 1. All you have to do is add that 4A over to the other side, and you have what your Y is equal to. Your Y is equal to 4A minus 1, right? Or you can say Y is equal to negative 1 plus 4A. It really makes no difference how we write our answer. I tend to write my A's first. Your book goes back and forth between the two. Okay, so far we have our Z, we have our Y, so the only thing that's left is our X. So pick an equation. You got 3 to choose from. Now, here's my suggestion. Again, it's a suggestion, don't have to follow it. I would stay away from equation 1 and equation 3, because notice that not only would we be plugging in an A for the Z's, but then for the Y's, you're going to have to plug in the negative 1 plus 4A or 4A minus 1, however you looked at it. But if you look at line 2, notice that there are no Y's. So this one's going to be a little bit easier to plug in and solve for X. So I'm going to use my equation number 2. So I'm going to say, okay, 4X plus 2. Now instead of Z, what am I going to write? Yeah, A is equal to 10. So go ahead, subtract. So 4X is equal to negative 2A plus 10. Divide by 4 to everything. And please, please, please simplify your fractions as much as possible. Keep them as fractions. They're easier. So this will leave you with a negative 1/2 A. And 2 goes into both. And we get 5 over 2. So we just have to remember, we always write our answer in terms of X, Y, and Z. So that means our X is negative 1/2 A plus 5/2. Our Y is right here, so 4A minus 1. And then we wrote a let statement, so that's our Z. So there's our Z. So you're doing exactly the same, and if you can get to this statement right here, if you can get a true statement, okay, we just want to take it one step further. Write a let statement for A, and then all you have to do is substitute. That's it. All right, so let's try one more, just like this. Okay, here we go. Example number 2. So take a moment if you need to. Pause the video, copy it down. Again, notice the X's are lined up, the Y's are lined up, the Z's are lined up, and the numbers are lined up. Everything's lined up the way it's supposed to. I'm going to go ahead and label this 1, 2, 3, so you know what I'm dealing with. Again, X's look a little bit easier to eliminate, but again, it is up to you what you want to do. So I'm going to manipulate my first equation, so that way I can use it with my third equation. So my third equation will be 2x minus 2y minus 7z is equal to negative 19. And if I manipulate this equation by, say, negative 2 to both sides, negative 2 times x will be a negative 2x, first equation. I don't have any y's, so I don't have to worry about that. Minus 8z is equal to negative 26. Add them up. Boom, gone. So minus 2y minus 15z. And what is this? Carry 5, so negative 45, if I did my math correctly. I think I did. All right. Now, this one, notice that 5 goes into both of these, but doesn't go into that one. So we can't eliminate it. That's fine, or reduce it, I should say. So brand new equation, call that number 4. All right. So now what I want to do to make equation number 5, go back. I haven't used my example number 2 yet. So I'm going to use 2, and I'm going to manipulate it with 3. Right. So 2 over here. So 4x minus 2y plus z is equal to 7. And my third equation, I'm going to multiply it by a negative 2 to both sides. Third equation should look like this. Negative 4, positive 4y, positive 14z, and that should be, what, positive 38? I think I did that right. Add them up. X is gone. We are left with a positive 2y this time, a positive 15z, and 38 plus 7 is 45. Notice, fourth equation and fifth equation are opposites of each other. So if I add these two equations together, fourth with the fifth, everything is going to cancel out. 0 is equal to 0, true statement. Right? So that means we have an infinitely many solutions. So what do we have to do? Right? We're going to write a let statement. Again, keep one variable as the a. So here's my let statement. I'm going to let z equal a. Great. And let's plug in something in order to solve for y and for x. Again, I like to start with my fifth and fourth equations, but if you look back at the top, we could have plugged in right here into the first equation, solve for x first. Doesn't matter. But I'm going to plug it into my fifth equation. So I'm going to say 2y plus 15a is equal to 45. So 2y is equal to negative 15a plus 45. Divide by 2 to everything. Again, keep it as a fraction. They will become your best friends. And you're golden. You got the y. So now we just need the x. Again, I'm going to go back to the top equation of x plus 4z is equal to 13. So I'm going to say x plus, what was it? 4z. So 4a is equal to 13. Subtract. X is equal to negative 4a plus 13. We got our x, or sorry, we got our z, we got our y answer, we got our x answer. So just remember to write your answer as an ordered pair. So your final answer will look something like this. Comma, a. Okay, and so now technically you can choose any number for a, right? If I choose 0 for your a, the z will be 0, the y would just be 45 over 2, and then this one would just be a positive 13, right? If you want to choose the number 1, great, then that's 1. This will be 45 over 2 minus 15, so 30 over 2, so 15. And then this will be 13 minus 4, so 9. So again, there's if you just start plugging in some values for a, the x's and the y's and the z's, you'll come up with a bunch of different points, right? X, y, and z's that would work for that system. Okay, so that's it. That is three variable systems. When you have a true statement, when you have a false statement, just write no solution. It's perfectly fine. And there are a few practice problems in your book that I'm going to assign on your homework. So now you're going to watch the other video that I have for you. Great.